Good morning, all of you. My name is Saikiran. I'm your chemistry lecturer. Today, our topic is structure of atom. In this topic, we will discuss first introduction. Introduction about atom according to Dalton's theory. After that, subatomic particles of atom. They are electron, proton, neutron, and their discoveries. And next, atomic models. In our syllabus, we have J.J. Thomson model, Rutherford model, Bohr's model, and next, quantum mechanical model of atom. Nowadays, we follow this model. In between these models, few developments is there, like Planck's quantum theory, photoelectric effect, atomic spectra, de Broglie's waves theory, Heisenberg uncertainty principle. And next, come to the quantum numbers. And last but not least, electronic configuration. We will discuss all these topics in detail from basics. Now we will start with introduction of atom. The word atom was derived from Greek word, that is atomio, which means uncuttable or undivisible. The term atom was proposed by John Dalton. The first theory also given by John Dalton. According to Dalton's, atom is the smallest particle. We can't further divide it. It will participate in chemical reactions, which means atoms are participating in chemical bond formations. And atoms neither be created nor be destroyed. And we already know that matter made up of molecules. Molecules made up of atoms. So, these atoms are called fundamental building blocks of matter. And atoms are combined to form compounds. These are combined in simple whole number ratio. For example, H2O. In this, two hydrogen atoms are combined with one oxygen atom. These are combined in simple whole number ratio. And one more important observation according to Dalton's, atoms of same elements having same properties, atoms of different elements having different properties. Let's understand this statement with example. Now, I am taking two chlorine atoms. And I am taking two hydrogen atoms. When compared to two chlorine atoms, the mass and size is same. When compared to two hydrogen atoms, mass and size is same. But when compared to chlorine with hydrogen atom, mass is different, size is different. So, atoms of same element show same properties, atoms of different element shows different properties. Properties like mass, physical properties and chemical properties. Let's see one more example, then you can get clear idea about this. Now, I am taking two containers. I have kept equal amount of water inside these containers. In the first container, I am adding sodium atom. In the second container, I am adding copper atom. In the first container, after adding sodium into the water, explosion will happen. In the second container, after adding copper into the water, copper go down and settle here. Because in the first case, the reactivity of sodium with water is very high. And in the second case, the reactivity of copper with water is less. Now, I am taking one more container. I have kept same amount of water inside this container. Now, I am adding one more sodium atom to the third container. What will happen? Explosion will happen. This is the proof for atoms of same element show same properties, atoms of different element shows different properties. This theory was able to explain three laws. First law is law of conservation of mass and law of constant composition, and third law is law of multiple proportions. Let's see one by one in detail. Now come to the first law, law of conservation of mass. This law states that matter neither be created nor be destroyed in a chemical reaction. This reaction is carried out in closed container or closed system. We already know that general chemical reaction contains reactants and products. According to this law, the mass of reactants is always equals to the mass of products. Let's see one example, then you can get clear idea about this statement. This is the combustion reaction. These two are reactants and these two are products. From reactant side, the mass of methane is 16 grams and the mass of 2 moles of oxygen is 64 grams. The sum of these two masses, we can get 80 grams. Now come to the product side. The mass of carbon dioxide is 44 grams and the mass of 2 moles of water is 36 grams. The sum of these two masses equals to 80 grams. The mass of product equals to the mass of reactants. This is the first law, law of conservation of mass. Now come to the second law, law of constant composition. This law states that a chemical compound always contains its constituent elements are present in fixed ratio and does not depend on its source and does not depend on method of preparation, which method we use to prepare. Let's see one example. For example, I am collecting water from different sources. Like I am collecting from river, from water tank, from tap, from bore. I am collecting water from different sources. I am indicating with H2O. This was fixed, and in this, 2 hydrogen atoms are combined with 1 oxygen atom. This ratio is also fixed. This formula and ratio does not depend on its source and does not depend on method of preparation. You can use any method to prepare water. We directly indicate with H2O. This ratio is fixed. This is the law of constant composition. Now come to the third law, law of multiple proportions. According to this law, when two elements are combined to form more than one compound, in these all compounds, one element weight is fixed and other element weight is present in simple whole number ratio. Let's see one example, then you can get clear idea about this statement. Carbon reacts with oxygen to form carbon monoxide and carbon reacts with oxygen to form carbon dioxide. When two same elements are combined to form more than one compound, in these two compounds, carbon weight is 12 grams in first compound The second compound, 12 grams. One element weight is fixed and oxygen weight is present in first compound, 16 grams. In the second compound, 32 grams. These weights are present in 1:2 ratio. When two elements are combined to form more than one compound, one element weight is fixed and other element weight is present in simple whole number ratio. This is the third law of multiple proportions. Now come to the drawbacks of Dalton's theory. The main and first drawback is it was failed to explain internal structure of atom. And the second drawback is it could not explain how atoms of same element show same properties, how atoms of different elements show different properties, and why they are combined. And the third drawback is it was failed to explain some experiments like when I am taking glass, I am taking silk, rubbing this glass with silk, electricity will generate. How this will happen? This theory was not able to explain. This is the introduction about atom according to Dalton's theory. That's it today class. In the next class, we will discuss subatomic particles of atoms. They are electron, proton, neutron and their discoveries.